Okay, next question is question number 4. It's about the simple harmonic motion, and this is a graph between displacement and the time. Question is state what is meant by damping. So simply decrease in the amplitude with time due to the loss of energy is called damping. Evidence that the motion of the ball is damped. Look, the amplitude is gradually decreasing. So this is actually the evidence. So amplitude is decreasing gradually with time. Next part is this. This equation is given and use the data to determine the angular omega frequency. Look, angular is omega frequency is equal to 2 pi over t, and from the graph, one wave is covered in 0.8 seconds. So this is the time period. So we can use this. Omega is equal to 2 pi over capital T, and T is equal to then 0.8. So 2 into pi divided by 0.8. The answer is 7.9 radians. Next question is determine the K. Look, this equation is a simple harmonic equation, but the general equation is A is equal to minus x omega square. Compare it. So omega square becomes 2k over m. So we can write omega under root 2k over m. And here the K is m omega square over 2, mass given 1.2. Omega 7.9 calculated square divided by 2. So the answer is 37 Newton per meter. This is the question. And the next part is, question is, show the variation with angular frequency of the amplitude A of the oscillation. Look, this is a graph. Look, when both frequencies are equal, free oscillation and the forced oscillation frequency are equal, there will be the resonance. So we have to draw a peak at this frequency, but don't make the amplitude 0, okay? Start it from any positive value, right? And the next, state 2 changes that will occur in the graph gradually increase from 0 to 1.7. So the angular frequency of oscillation is gradually 2 changes. Number 1, peak at the lower, because the surface is horizontal, some sand is sprinkled, friction increases, so peak at the low amplitude due to the increased damping. And the next, flatter peak like this. Suppose this is the graph, so now we have to draw this small peak and it is flat, right? If we have to draw this, it's like this. This is a graph, okay? And the next question is question number 5. State what is meant by acoustic impedance of a medium. It is a product of density of the medium and speed of sound in that medium. So Z, rho multiplied by V, density of the air multiplied by speed of sound in air. And the next question is, we have to calculate the acoustic impedance, rho into V, density given, speed given. So this is the answer. And the next part is, state what is meant by attenuation of the ultrasound, reduction in the power of the sound wave when it passes through the medium, when it is transmitted through the medium, right? And the next, ratio is required, intensity of the ultrasound to the medium, intensity of the ultrasound entering the medium, transmitted intensity and the original. Is E minus mu x, linear absorption coefficient mu. So it's given E is equal to minus 0.24 into 0.45, and the answer is 0.8976, so 0.90 approximately, right? And look, this data is given here in the question. And similarly, for the layer of the muscle, E minus mu x, E minus 0.26 into 2.1, 0.6169, so approximately 62. So first one for the fat, second one for the muscle. And the next important question, use the information, use the answer from B and C to determine the fraction of the intensity entering the layer of fat that is transmitted to the layer of the muscle. So fraction is equal to alpha, beta, beta. So alpha, which is reflected, first transmission, second transmission, so total becomes 0.4. This 0.98 for the alpha, this is B1, this is B2, so the answer is 0.54. And the next question is question number 6. This is about telecommunication. Question is, determine the frequency of the carrier wave. Look, this is the carrier wave, and this time is half of this 10, so 5, and the unit will be microsecond. So time period is 5 microsecond. It's 5 into 10 power minus 6, so 1 divided by t, so it becomes approximately 2.0 10 power 5 hertz. And then we have to draw for 3 bands for the AM. This is carrier wave frequency, 200 kilohertz, mean 2 into 10 power 5. So this is carrier frequency band, loudest sound. And then the signal frequency is, look at this, it is 10 kilohertz, mean 1 into 10 power 5. So 200 minus 10, 190, 200 plus 10, 210. So this one is the lower side band, this is upper side band, this is carrier frequency band. So 190 to 210, this is called bandwidth of the radio station, and no other radio station can be operated in this lower side band, upper side band, and carrier. If you have to add here the further, so it becomes like this. You have to join like this. And then question number 7 is, describe the principle of computed tomography. So CT is actually the X-ray. So in CT scan, X-rays are used to scan section of object. Images are taken at different angles for the number of the sections of an object. All images are combined of many sections for the object. This combination gives 3-dimensional image of the whole structure of the image. So this is actually the principle of computed tomography or CT scan.